Rapid change in the sky this morning here in southern Wisconsin. I woke up around, I don't know, 6:30, and we had a brilliant red sunrise, with the sunrise on the east be illuminating the clouds to the west. It was really quite dramatic, and then it's completely gotten solid overcast here in about an hour and a half. And you can see on the surface map, though it's not in motion, one gets the idea that there's a band of snow moving its way gradually towards the north and east, and that will invade during the day today. I have a feeling it's going to snow heavily for a short period of time to accumulate the 2 to 3 inches that are forecasted for us. And then it'll warm up a little bit, and we might coat that snow with freezing rain, which is a miserable winter weather element. Nobody particularly likes it, and it's dangerous when you're out and about. So the weather map this morning has really what looks like a weak central region of low pressure over the state of Kansas. That has, nonetheless, as weak as it looks, been responsible for an extraordinary snowstorm in the Denver metro area and parts of southeastern Wyoming. So the high plains immediately to the east of the Rockies, the highest peaks in the Rockies, a really outstanding snowstorm. I'll show you a little bit about that in a minute. But the bigger weather system in terms of its aerial extent is the region of high pressure that's over central and southern Ontario this morning. And that was responsible for our really brilliant 2 days of sunshine over the weekend, and now it's moving off to the east. When it was sitting more directly over us, we were enjoying light winds, very brilliant sunshine, and a really great weekend. And next weekend looks even warmer with similar conditions, but we do have this current week to contend with in between, especially today and tonight. It's going to be a little bit messy. So let's say a little more about this storm in Colorado. I really can't dwell on it, unfortunately, but it was really a monster storm, and it was well forecasted. In fact, in some cases may have been slightly over forecasted. But the topography of Colorado and Wyoming is so complicated, and you don't see much of that on this map. But there's extraordinary local variations in the topography, and those variations in the topography really have a huge role to play in how much snow individual locations get. But this is what information from the U.S. National Weather Service in Denver, Colorado. This storm through 7 p.m. last night, and it was still snowing past that time, so this is not yet the final tally for the 2021 March snowstorm, but it was the fourth greatest snowfall total from a single storm since at least 1881 in Denver, Colorado. And the greatest storm was December 1st through 5th, 1913, where I think it was 34.7 inches of snow fell, and it was 27.1 in the storm over the weekend. So that's more than 2 feet at Denver International Airport. Boulder had more than 2 feet in neighboring Boulder. There were places that had as high as 37 inches of snow. That's the top total I saw, again, through 7 p.m. last night in the Denver and eastern part of the Rocky Mountains and plains of Colorado. 37 inches of snow, but 27 of it fell at Denver, which is pretty unbelievable. And here are the temperatures that go along with our map this morning. Really warm and toasty down in the southeastern United States. Not terribly cold here. 31 is not so bad for March 15th. At 7:30 a.m. local time, 26 at Green Bay. You can see it's considerably colder where the snow has been falling and where the clouds still exist. So 21 degrees in Denver and Boulder, that's pretty cold for a March, but that's a function of the snow. That'll warm right up. It'll go right back into the 50s in almost no time. One of the reasons I don't think I could stand living there, seeing so much snowfall and then have it suddenly melt on the next day or two because of strong winds across the high mountains just to your west. I don't think I could stand it. Really cold in New England states, single digits everywhere north of Boston, actually, Maine, Vermont, New Hampshire. And that's the cold spot in the country. It's generally pretty nice around much of the rest of the country this morning, with the exception of course, the nasty weather in Iowa, Illinois, and heading into Wisconsin. And interestingly, you see, the dew point map for this morning tells some of the story. So this is the surface dew points. Now, only dew point temperatures right at the ground, and that's from 7:30 a.m. But boy, isn't it obvious the curlicue associated with the cyclone that was in Kansas. So on the eastern side of it, where the flow is from the south, the dew points are ushered northward, and they're really quite high. 41, 43 in Kansas City and St. Louis, 65 in Jackson, 68 in New Orleans, really high dew point. And that air is moving straight northward, and then it's caught in the counterclockwise circulation of the cyclone in Kansas, and some of it is ushered off to the west. And notice the temperature at Denver is the same as the dew point. So it's 100% relative humidity in Denver at 21 degrees. Same was true in far western Nebraska. So this air is saturated. It's not as moisture laden as the air down in New Orleans, but it's saturated, so it's still likely snowing in the high terrain. But a beautiful example of how the circulation of the mid-latitude cyclone, which we're just about to begin talking about in lecture after the exam, how that circulation, of course, deforms all of the variables in its wake, in its vicinity, the water vapor content, the temperature structure. We're going to see how it all gets deformed by the circulation of the storm. But you can see today the circulation around the storm really deforms the moisture content as measured in the dew point. And 22 dew point here with a 31-degree temperature, that means we got a 9-degree dew point depression. So my guess is when we look at the radar, we're going to see the radar echoes butting up against the central southern part of our state and without making much progress in the last hour or two. That's because precipitation undoubtedly is falling out of the clouds well above the ground, but it's falling into a subsaturated layer underneath, and so evaporating or sublimating away before it gets to the ground. That can't last forever, because every time you sublimate a snowflake into the air, you make the relative humidity go up a little bit. And once the relative humidity gets to 100%, then the next snowflake that falls through that air will not sublimate away, and it'll reach the ground. So that's going to gradually do that to us today. In fact, we'll have a great example of going, so the dew point temperature is 22, the actual air temperature is 31. My guess is by the time it starts to snow, we're going to bring the dew point and the temperature close to the same value, and they'll all meet right at the wet bulb temperature, which is something like 26, 27. So that's about what we're going to see, I think, while it's snowing this afternoon. So really interesting microphysical stuff going on. Here is the satellite movie over the continental 48 and adjacent waters. Boy, what a beautiful cyclone in the central part of the United States. Look at that thing. It's got a cloud street that comes across Mexico. Here's the cold frontal portion of it with popcorn-looking clouds. These are convective clouds. It's erupting in thunderstorms, sometimes thunder snow, probably in Iowa and Illinois. I'm not sure we won't get a little bit of thunder mixed in with our snow this afternoon, so keep your ears open for that. And then the circulation center in Kansas, just as the surface map seemed to suggest. And then there's a storm off of the East Coast. Look at this sort of smoky-looking cloudiness coming off the coast of Maine. That's low-level stratus cloud, same off all of New England. That's because the air is so cold coming over relatively warm water. It gets less and less prevalent as we move into mid and late March, but this is something that happens all the time in the wintertime. But beautiful sea smoke turning into, I don't know what happened there. Son of a gun. It'll come back. But you can see this beautiful sea smoke coming off the coast in the Gulf of Maine. And then off the west coast, we'll get a better view of this in just a minute. There is a storm just north of the San Francisco Bay Area that's quite kind of small in scale and probably not very cold clouds, so it's not probably raining very much, maybe drizzling in Northern California with that storm. And we'll see something much farther west when we get out that far in a minute. But the radar is interesting today. There's an annoying loading images icon here that gets right in the middle of the circulation center. But luckily, it doesn't obscure the echo that's coming along the cold front and then on the in our vicinity as well. And here we are in Madison. And you can see there's echo over us, which if it were a normal saturated column underneath, you might already see the snow falling. But that's not the case because the air is unsaturated in at least the lowest part of the atmosphere, and that probably extends through some distance. And gradually the snow that's falling in these elevated echoes is going to moisten the column, get it to 100% relative humidity, and let subsequent snowflakes fall all the way to the ground. Although the temperature will be reduced by that sublimation to something like the wet bulb temperature, it would probably be in the high 20s. So, but look at how intense this echo is. This is all pretty intense. It's populated with a little bit of orange, a lot of yellow, and those are moderately intense echoes. So I think when it does start to finally snow and the snow begins to make it to the ground without evaporating or sublimating, I think we're going to see a pretty heavy rate of snowfall for a period of time this afternoon. And you notice that this isn't making great eastward progress. So once it begins over us, it's going to hang around for a while. So it's going to be kind of an interesting wintry day. The first one we've had in at least 3 weeks. So it's been an incredibly benign period. But a very beautiful, well-structured storm on a lot of different levels. And here's the precipitation over the state of California and some open cellular convective clouds here at the mouth of the Columbia River and then also near about San Francisco Bay. So let's take a quick peek now at the satellite movie over the west coast of the United States and at least the eastern and central Pacific Ocean. So here's the storm off the coast of California. Notice the cloud tops indicated in this infrared picture as kind of light gray, not the bright white ones, which are higher cloud tops and therefore radiating a colder temperature. This is kind of a low-level cloud mass, and it's not got as much precipitation associated with it as a result of its not so great depth. And then here's more evidence of cold air coming off the Bering Sea to the south of the Aleutians. It's one after another. The last week was very active in that regard, and it looks like it's beginning. This week's beginning to have some of the same appearance. But the main event is this big storm that's at about the dateline, actually west of the dateline, and one really can't get a nice view of it. I wish I had a different satellite to look at it. But my guess is that's a very impressive, very intense mid-latitude cyclone, and perhaps by Wednesday, it'll slide a little bit more either into the Bering Sea or further east into the southern Gulf of Alaska. We'll get a better view of it, and I'll search around for some historical views of it if it indeed turns out to be as interesting as it looks from this oblique angle. So an interesting weather day today. Keep yourselves alert if you're on the road, but it won't last long. That's the nature of March snow. The French have a proverb: snow in March is like a visit from your in-laws. It's never pleasant, but it doesn't last that long. So we'll see whether or not that's true. It usually is.